Now, after seeing the types of adsorption, let's move to the next topic, and that is adsorption isotherms. See, let us take a container like this and put some solid substance in it, and let's take this as movable piston. See, there are these gas particles, and this is our solid surface. Now, as we put some weight over this piston will move downwards, and let us say it is in this position now. Initially it was here, now this second one, it is the final position of this piston. Now moving from this position to this position, from here to here, obviously here at this first position, the volume over which the gas was expended is relatively more than this second volume after the compression. So as the volume decreases, pressure of the gas will increase by this PV equal to nRT. By this ideal gas law, this P and V are inversely proportional, because P will be nRT by V. As we decrease the volume, pressure inside will increase. So as we know, if we increase the pressure, the rate of adsorption will increase. That means more and more particles of gas will adsorb over this solid surface. What do I mean to say? See, we have seen two factors, that is pressure and temperature, which affect this rate of adsorption. Let's take this temperature as constant. That means this system is at constant temperature, and we are only varying this pressure. And let this mass of adsorbate means these particles which are adsorbed on the solid surface, let x be the mass of these adsorbate which get adsorbed on the solid surface at pressure P1. Suppose the pressure is P1, and let the mass of this surface, this adsorbent, be m. This x is mass of adsorbate and m is mass of adsorbent, the solid surface. Now let us increase the pressure. Increasing pressure means put some more weight over this piston. This will move downwards and pressure inside will increase. That means more and more particles will be adsorbed over this surface. That means this x will increase. Now see, as we increase the pressure, the mass x, this is the mass of adsorbate which is adsorbed over the solid surface. Relatively this increases. Now let's make a graph. This is x by m. What does that mean, x by m? It is the mass of adsorbate per unit mass of adsorbent. That means how much mass of adsorbate is adsorbed over mass of adsorbent. And let's sketch it over P. P means pressure. When pressure is 0, this x by m, relatively it will be 0, approximately, Now as we increase the pressure, you have seen this x will increase. that means this x by m ratio will increase. Now as we go on increasing the pressure, this x will increase. Now after some stage, as we go on increasing the pressure, the rate of increase of x will not be same, the rate will decrease. That means this curve will flatten up over some particular pressure. Let us take this pressure as PS, and now I'll explain what I am trying to say. I mean to say that let's consider this system as like this. This is our solid surface and inside pressure is P1. Without increasing pressure at this P1, some molecules will try to adsorb over this surface. As the time will go on, more and more particles will try to adsorb, but after some time, some molecules, some particles over this surface will also dissolve. That means they will leave this surface and move to the gas phase. As the time goes on, the rate of adsorption just becomes equal to the rate of desorption. That means the number of particles adsorbed is equal to the number of particles that are being dissolved. That means rate of adsorption becomes equal to the rate of desorption. Note, P is constant. We are not changing pressure. Now what is this? Rate of adsorption is equal to rate of desorption. That means the number of particles that are being adsorbed over the surface equal to the number of particles that dissolve themselves from this surface. That means there is a kind of dynamic equilibrium. That means by naked eye, if we see this system, we will think that the adsorption has stopped, but actually it's not like that. It is the rate of adsorption is just become equal to the rate of desorption, and this type of equilibrium is known as dynamic equilibrium. That means if we keep the pressure constant, after some time a state of dynamic equilibrium will be there. Now if we increase the pressure, now let's put some weight, and now pressure is P2. More and more particles will dissolve. After some time, some particles will try to dissolve, and after some more time there will be a state of dynamic equilibrium. Now at pressure P2, dynamic equilibrium. This P2 is greater than P1. At this P2, the amount of substance which will be absorbed over this surface X will be greater than, let's take this X2, the amount which is adsorbed at pressure P2, and at this P1, let us say X1 was absorbed. Obviously this X2 will be greater than X1. That means on increasing pressure, the rate of adsorption will increase. I hope it is sufficient.